example, the difference from what we're doing now. They're saying you should solve for theta, but instead of starting from 0, so we've been doing this one. Theta is an element from 0 up until 306, which means we're only working on the first cycle only. Now, in grade 11, that one was for grade 10. Grade 10, we are going to work only on the first cycle. When we get to grade 11, you can work in any cycle. They're going to ask us in different cycles. For example, here they say start from minus 360 up until 360. What is this question asking, guys? We repeat this again. They're saying we give you sine theta, which is going to be equivalent to 1 all over 2. Now, sine theta is a trig function. Trig function can be given as f of x is equivalent to the sine of theta. And then y can be written as the sine of theta. So in other words, here's what they are saying here. They are saying, what should the learner write here? What should the learner write here such that they are going to get 1 over 2? What are the values of theta that are going to give us our y value as 1 over 2? So if you look at the following here, I did draw a line here whereby we just push this line and put it further. Let's just show you something here. So if you take this line, I think it's already done. So when y is equal to 0.5 here, they're asking what are going to be the numerical values that are going to correspond with this thing. Now, what they are doing is then to say, we can ask you from any place here. I mean, the only piece that I just showed you, it's from minus 363 up until to 810. But the examiner can ask you to give them what are going to be the values of theta that are going to make y. This is our y here. This line here represents our y. And then you will check with how many times do you touch the graph. Given this range, how many times do you touch the graph here? You are touching it many times. So here you can have, okay, if we say 0, if we put 0 is to, let's go to 0 is to 360. I don't know things. Okay, 0 is to x, and then x should be less than 360. How many times are we touching now? If I give you this range here, how many times are we touching the graph from 0 up until 360? We are touching it 2 times. So it means there are 2 solutions. There are 2 values of theta that are going to make that to be possible. But are those the only 2 values that are going to make that to be possible? No. It depends what are they asking here. For example, here they're asking how many values of theta like that between minus 360 up until what 306. So if they gave us the domain here, if they gave us the domain, then we can go and check, okay, if they're saying minus 360 and minus 360, let's do that here. Instead of 0, we are going to put minus 360. If you put minus 360 here, how many solutions do we have? So our solutions are no longer 2, but they are how many? They're 4. So it's possible here, it's possible here, it's also possible here, it's also possible there. So what are they saying basically? They are saying, they're asking you which values, if we substitute them here, are going to give us 1 over 2. That's what they're asking. Which values, when we substitute them there, they are going to give us 1 over 2. So the first value that we can get, we know how to get it by now. We said if you have the sine of theta, which is going to be 1 over 2. Theta is going to be equal to the sine arc 1 over 2. And then if you type this in your calculator, it says when theta is equal to 30, then you are going to get 1 over 2. That's what this thing is saying. When theta is equal to 30, then you are going to get 1 over 2. Let's prove that. Let's just prove it. So if we have the sine of 30, what is the numerical value? No, we just want, if we put sine 30, the angle is 30, then the numerical value that we get is equal to what? 1 over 2. Now the question then is this: is this the only angle which is going to give us half? That's what they're asking here. Is this the only one which is going to give you half? No, we know. Because sine is not only positive on the first quadrant, it's also positive on the what, on the second quadrant. Then we went on to say, okay, this one, according to the first quadrant, we know it's going to give us half. So theta is equal to 30. We accept that one. But there's also another value which is going to give us half. which is going to be given by 180 degrees minus 180 degrees minus 30, which is our F angle again. So if you subtract 30 here, we say, okay. The other value which is going to give you half is 150. Go and check it then. If I say, look at the following. If I say 150, sine 150, does it give me a half? Yes, it gives me a half. So these are the values that when I substitute for theta, they are going to give me what? A half. Are these the only value? No, these are not the only value. There are many values which are going to a half. But depending on what the person is asking you, if the examiner is asking you, like here, they are saying between minus 360 up until 360, then we need to go and find other values. We know how to get the values in the first cycle. Now we need to go and find the other values in the other cycle. What is the principle that I want to introduce now? There is a principle called the general solution. Now, what does the general solution say? It says this, it says, every time when you add 360 for cos and sine, it's going to give you the exact numerical value. What do I mean by that? Agree you have 30 here. If you add 360 on 30 and then you check it in a calculator, it's going to give you the same numerical value that 30 gave you. That's what they're saying here. That's the principle. If you add it or you subtract 360, then it's going to give you the exact numerical value. So look at the following. What do we mean by it? Let's just check it. If I say to you 30 plus 360, if I say 30 plus 360, what am I going to get? 390. Let's go and check if this is true. They are saying if I say the sine of 390, what should it give us based on what I just said here? It should give us 1 over 2. Is it true? Does it give us 1 over 2? Yes. And then the other thing is this. Every time when we add 360 on a numerical on an angle, it's going to give you the exact numerical value. So if we can go to 309 and still add 360 here, what are we going to get? 750. Okay? Come and check here. If you say the sine of 750 here, does it give us 1 over 2? Yes, it gives us 1 over 2. All these different values are going to give us whatever it is, are going to give us the exact numerical value. Now, how do you know which one to give us? How do you know which one not to give us? It's going to be determined by this here. Here they're saying we want values between minus 360 and what and 306. Then we can come and check here. Let's come and check this one, for example. Is 390 part of the solution? Actually, they said we want values between minus 306 okay? Up until what? Up until what? 306. Is 390 part of the solution? Can we accept 390? Whenever they want values between minus 306 and what and 306. If you get 309, is it part of the solution? It's not part of the solution. So 309 is not part of our solution as much as it gives us 1 over 2, but it's not part of the solution. Now, what else can we say then? We can also check 750. That's 750 part of the solution. It gives us half, but it's not part of the solution again. Now let's try something else then. Let's try to subtract 360 then. Agree with added 360. Let's try to subtract 360 and check if that gives us a half. So if you have if we say 30 minus 360 degrees, what is going to be 30 minus 330 degrees? You are going to get what? Minus 330 degrees again. Okay, come and check it. Minus 330 gives you that. So if you can say minus 330, does it give us a half? Yes. Yes, it gives us a half. So it's part of the solution. Can we check here? Is it between minus 360 and 360? Is it between? So we accept 330. We didn't accept 390. We didn't accept 750. Okay? But we do accept 330 because it's part of the what of the solution. Let's subtract again here with minus 330. You can say minus 330 minus 360. Minus 330 minus 360. We know what is also going to give us 1 over 2 again. But the question is that, is it part of the solution? That's what we should ask. No. It's not part of the solution again. Yeah, as much as it gives us half, because we can check it, we can say minus 330 minus 360. It gives us what? Minus 609. Then you can come and check it in your calculator. Does minus 609 give you that? It gives you half again. But we can't accept minus 690. Why? Because it's not what part of the solution. But if the examiner gave us something like this, they said solve for theta, and then they said theta is an element between minus 720 up until to minus 108. We're definitely going to accept it. Does it make sense then? Okay, what else? So which values do we accept? We said we accept theta. Theta is part of the solution again. Which other value do we accept? We said we also accept what? 150 again. We also accepted 150. And then we said we're also going to subtract, we're also going to accept what? Theta is equal to minus 330 again. Now we saw which, when we checked graphically, how many solutions should we have? We should have 4 solutions again. So we can then say, okay, let's go and check with 150. If we go to 150 and then we minus 360 here. 150 minus 360, what do you get? 150 minus 210. Minus 360. And what you get what? And then 200. You accept minus 210. Yes, we definitely accept minus 210. And then we can say that it means all in all our solutions are going to be given as theta is equal to minus 333. Theta is going to be equal to minus 210. Theta is equal to 30, and theta is going to be equal to 150. Then this is how we solve it then now when we are in grade 11. Again, in grade 11, we're saying which we are not going to work only on the first cycle. Again. We can work with the negative numbers, we can also work with the what with the positive numbers. So this is your activity here.